Alright, so what we'd like to work on now is the next worksheet, which is rates, canceling units, and a clever equation. Right, so this is a short worksheet. So I want to actually skip down to number 2 and explain this one a little bit. I think this will be a little easier one to start with, and then we can move on to the other questions. Right. Alright, so when I'm looking at this, so we're given an equation and we're given a scenario to use the equation, right? But let's first think about how this equation can be useful and why it works, right? So what you need to remember is that distance equals rate times time, right? This is a very common equation that you probably used a number of times, right? So one thing we want to keep in mind is that that if we have two people, right? So in the problem, right, it talks about we have a roommate and we're talking about ourselves, right? So we have roommate and us, right? So I'll just put me. So the roommate would have one equation, right? Distance equals rate times time. And we would have our own equation, distance equals rate times time, right? Except one thing in mathematics that we have to think about, though, is that our distances aren't necessarily going to be the same, our speed and our time. So what we do to differentiate this is we use subscripts, right? So I could call this D1, R1, and T1, right? I could call this D2, R2, and T2, right? So I'm using the ones to denote the variables for the roommate and twos to denote the variables for you. So another key thing here that we're told is that we have the same class, right? So the scenario is your roommate walks at 3 miles per hour and it takes her 8 minutes to walk to class. And we have the same class, but we can walk a little faster at 5 miles per hour. So we're wondering, how long will it take us to walk to class, right? So the trick here is that we know that since we're going to the same class, right, that D1 must equal D2, right? That's what's implied, right? So we live in the same dorm, right? We're roommates, and we're going to the same class. So you would, that one would assume that the distance would be the same, right? We're going the same route, right? So if D1 equals D2, then I get this equation, right? Because I set these two equations equal to each other. So we get R1 times T1 equals R2 times T2, right? So now I can just plug in these values and solve for the unknown, right? So R1 is 3 miles per hour. T1 is 8 minutes. R2 is 5 miles per hour. And then we have times T2, right? That's what we're trying to figure out. So one thing you want to notice is that we have the same units on both sides, right? So as long as my rates are in the same units and my times are in the same units, so this would be in minutes, then we can use whatever units we would like, right? Because these units would end up canceling. If I divide both sides by miles per hour, that's gone. If I divide both sides by minutes, that's gone, right? So that's one way to look at it. Another way to look at it is the unit here would be miles per hour times minutes, right? And that would be on both sides. So we have the same units on both sides, right? So that means we're in good shape, right, to use whatever units that we would like, right, as long as it's consistent. So we have to use the same units for the rate and the same units for time on both sides. But other than that, this equation can be helpful. So if we're doing like kilometers per second for speed, then as long as we're doing that to both sides, then that's fine, right? So here, if we solve this, we would end up getting 24 equals 5 times T2. So if I divide both sides by 5, we end up getting 4.8. So T2 equals 4.8 minutes. Right. All right. So let's go to the problem number 1. All right. So we're given this equation: C1 times V1 equals C2 times V2. So here we have a solution mix at a specific concentration of 5 grams per milliliter, and we need 100 gallons mixed at 4 grams per milliliter. What do you do, right? So if we plug in what we know, right? So we can let C1 be 5 grams per milliliter. And then V1, so we have a solution mixed at a concentration of 5 grams per milliliter, and we need 100 gallons mixed at 4 grams per milliliter. So I would let, so in other words, what we're trying to find is V1, right? What's the volume for that we need to mix with this concentration, right? So we could do 5 grams per milliliter times V1 equals concentration 2, which is 4 grams per milliliter, and then we want to multiply that times the other volume, which is 100 gallons, right? So again, these are the same units on this side, right, for the concentration. That's good. So we need these to be the same, right, the volumes. So gallons, gallons, and gallons. So now what I have is 5 times V1 equals 4 times 100, right? So if I divide both sides by 5, I get V1 equals, so this would be what, 80, right? So it'd be 80 gallons, right? So there'd be the solution for that one, right? So with these, we're just plugging in what we know and solving for the unknown, right? Alright, so number 3, it says we have a fixed budget for flooring in your new home. One type of flooring at $4 per square foot covers 89,280 square inches using your budget. The more expensive flooring at $6 per square foot will cover how much flooring on your budget, right? So R1, right, is the rate, so we'd pay $4 per square foot. And then we can multiply that times the 89,280 square inches, right? This would equal, so we could do the $6 per square foot, and then we would multiply that times A2, right, area 2, right? So notice here that my price is in dollars per square foot, but my area is in square inches. Remember, that's okay because I have the same units on both sides, right? So it'll all work out, right? So to solve this for A2, right, we would take 4 times 89,280 and then divide by 6, right? And this will give me A2. So if you do that, you should get 59,520, right? And the unit for this would be in square inches, right? Square inches, because it's the area on this side is in square inches, right? Alright, so looking at number 4, so it says Janine eats a fourth a cup of oatmeal per day, right? So that's a rate, right? So 1/4. My time is 36, and then her husband has a rate of 1/2. We want to know how much time that he'll take, right? That his will last. So we just plug these in and solve, right? So it's important to note that T2 will equal something, and then the units will be in cup per day, right? Because that's what the other rate unit is, right? Right there. So if we solve this, right, so if we multiply both sides times 2, then what we would get is 1/2 times 36 equals T2. So then 1/2 of 36 is what, 18, right? Right. right? So we'd get 18 cups per day, right? So then we go down to number 5, right? So something very similar. So we have M, which is molarity, right? And V would be my volume, right? So it says we have a solution with molarity of 10 to negative 3 moles per liter, right? So this would be my molarity. So 10, negative 3, right? Could be M1. And then the volume associated with that, we don't know, right? So this would be V1. And then my second thing, I know that I have 1,000 milliliters at 10 to the negative fourth, right? So M2 would be 10 to the negative fourth, and then V2 would be 100 milliliters, right? So volume 1 is going to be in milliliters, right? Because again, this is in milliliters, right? This volume. So if I solve this, I would need to divide both sides by 10 to the negative third, right? So V1 would be equal to this. So take 10 to the negative fourth times 100, divide by 10 to the negative third. And in doing so, you should get 10, right? So V1 would be 10 milliliters, right? So then lastly, number 6, so it says you wish to count the number of bacteria in 1 milliliter of a solution, but there are too many to count. So you mix 1 milliliter with 9 milliliters of water to dilute it, and then draw 1 milliliters of the new mixture. Still too many ways, so you now mix with 9 milliliters of water and draw 1 milliliters of this new solution, and now count 75 nasty little bacteria swimming around. How many bacteria are in the original solution? Right, so this one is probably the hardest one of the questions on the sheet, right? So we need to think about this a little bit, right? So one thing to note is that we have 3 different solutions in this problem with 3 different concentrations, right, of bacteria per milliliter. So we can relate these in a formula as the following, right? I can say C1 times 1, equals C2 times 10, right? So this is relating one mixture, and then I can also make another equation, C2 times 1 equals C3 times 10, right? So notice that both of these have C2 in the equation, right? So what I can do is I can solve both of these for C2. So to solve this one for C2, you end up getting C2 equals, so this would be C1 divided by 10, right? And then for this one, C2 would equal C3 times 10. So if I set these equal to one another, I would get C1 divided by 10 equals C3 times 10. So if I multiply both sides times 10, I get C1 is equal to 100 times C3. Right, so that makes it just a little easier to work with, right? So we're told that the third concentration is 75 bacteria per milliliter, which means that the first concentration, right, we would need to solve for that, right? So the first concentration would be 100 times the 75 bacteria per milliliter. So 100 times 75 gives me 7,500, right? So 7,500. And the unit here would be bacteria per milliliter, right? So the thing here to recognize how we got these equation, right, is we're mixing 1 milliliter with 9 milliliters of water, so that makes it 10 milliliters total, right? So that's how I got those numbers, right? And then we're drawing another 1 milliliter, which is here, and then we're mixing it with 9 milliliters of water, so that gives me 10 total, right? So that way you can see how I got these 1s and 10s, right? All right, so that's all I have for this worksheet. Let me know if you have questions.